Today we are going to finish this lesson, the motion and time. So we have to recollect the important points from this lesson. In previous classes you learned about all this motion, rest, uniform motion, non-uniform motion and types of motions. You have learned. What is called motion? If an object is said to be in motion, if it changes its position with respect to its surroundings. If you learned the example also. Here is a bus. Here is a train. Which one is in motion? Car. Car is in motion with respect to its surroundings. It changes its position with respect to its surroundings in a given time. So the car is in motion. So next we move to rest. If an object is at rest, if there is no change in its position, with respect to its surroundings, that object is said to be at rest. Okay, next, uniform motion. What is called uniform motion? If a body covers equal distances in equal interval of time, that object is said to be uniform motion. Next, non-uniform motion. Okay, if a body covers unequal distances in equal interval of time, okay, that object is said to be uniform, non-uniform motion. Next, we come to types of motions. Okay, how many types of motions we have learned in previous class 3? What are they? Translated motion, rectilinear motion, curvilinear motion, rotating motion, oscillating motion. Okay, in translated motion we have learned two. Again, we have learned two motions. Okay, next, second, rotated motion, third, oscillating motion. Have you understood, children? What is called translated motion? Okay, if all particles of a moving body moves in the direction of in the motion, that body is said to be translated motion. Okay, again, in translated motion, we have learned these two topics. What is called rectilinear motion? If a body in translated motion that moves in a straight line, the object is in rectilinear, is said to be in rectilinear motion. Next, curvilinear motion. Okay, if a body in translatory motion that moves in a curved path, that is called curvilinear motion. Okay, next, rotating motion. If moving parts of an object, that all the particles in a moving body that moves in a circular path, that object is said to be in rotatory motion. What is called oscillatory motion? To and fro motion of an object that fixed at a point and always follows the same path, that motion is said to be oscillatory motion. Okay. Uniform motion. Can you give an example for a uniform motion? Yes. Here, uniform motion. The clock. Example of the uniform motion is clock. Okay. Are you understood? Clock. In clock, the hands of the clock, minute hand, second hand, and hours hand, they move equal distances and equal interval of time. So the clock is the main example of the uniform motion. the object is moves like this. So currently hill station, bus moves on a hill station. That is the best example of curvilinear motion. Rotatory motion. We have understood about rotatory motion. Next, blades of the fan. Fan is the best example of rotatory motion, and the earth also the best example of the rotatory motion. And oscillatory motion. Okay, swing is the best example of the oscillatory motion, and the needle of the sewing machine, and pedestal fan, stand fan also the best example of the oscillatory motion. Have you understood this class, previous class? Okay, children? We have learned about time. Okay. Time measuring instruments or watches, electronic clocks. And digital clocks. Etc. Okay. Time measuring instruments. These are called time measuring instruments. And also the basic unit of time is second. Basic unit of time is second, and the larger units of time or minutes and hours. It is second is denoted as s small s. Have you understood? Minutes are denoted as MIN, small MIN. Okay, minutes. And hours, small h. It is denoted as small h. Have you understood, children? Speed. Have you listened? The word speed. Have you ever listened the word speed? Many objects in the world around us, they are moving. Okay. To compare how fast they are, we need to know their speed. Okay. You may have observed the speedometer in motor cars, bikes, on bikes. You have observed. Okay. How they are? They are in circular in shape. The needle is moves like that. The scale is here. Okay. This is called speedometer. Okay. This speedometer, to calculate speed, we use speedometer. Okay. This speedometer shows us speed of the vehicle. Speed of the vehicle in kilometers. Have you understood? In kilometers. Okay. This is in circular in shape. You have observed on your bikes, on your father's bikes, and in cars, buses. You have observed. Okay. The speedometer is in circular shape and needle like this. The scale is here. Distance traveled by the vehicle. Distance traveled by the vehicle. Have you understood, children? Okay. It is in some vehicles it is in circular in shape and some vehicles that is odometer is like this rectangular in shape. Okay, that is the needle and point is here. It shows the scale is here. It shows the distance covered by the vehicle. Have you understood, children? What is called speedometer? Speedometer shows us speed of the vehicle in kilometers. What is called odometer? It shows the distance traveled by the vehicle in kilometer per hour. In kilometer? No, kilometer per hour. Have you understood, children? Exact time when you started from your home. Okay, suppose I will give you some examples here. Speed note the exact timings and the changes in speedometer. Here given here like this. For example, speedometer reading is speed. It is called speed. Corresponding time. Okay. You started at school. Suppose you started at gone to a market or any other place on your father bikes. Started at 9:10 a.m. At your house you started at 9:10 a.m. Okay. The speedometer shows 0 speed, and at 9:15 a.m. the speedometer shows 20 at 20, and 9:20 a.m. the speedometer shows the speed 30. Okay, the speed of the vehicle or different. Okay, have you observed here? The speed of the vehicle or different speeds it shows. Okay, at different times. Does the speed of the vehicle remain the same throughout the journey? No, it doesn't. The speed of the journey throughout the speed of the vehicle throughout the journey, it is not same. Okay, next we experience in our daily life the most of the vehicles in motion, they don't have the same speed throughout their journey. Okay, to express the speed of the journey, we consider its average speed. We consider its average speed. For this, we have to learn the formula. We have to know about the distance traveled by the vehicle, and also we have to know the exact time intervals. Okay, time is taken to cover the distance. Okay, then we have to learn the formula average speed of the vehicle. Average speed of the vehicle. Average speed of the vehicle is equal to distance traveled by the vehicle. Distance traveled by the vehicle by divided by time taken to cover the distance. Time taken to cover the distance. How to calculate the average speed? The formula to calculate the average speed of the vehicle is distance traveled by the time taken. Okay, have you understood this, children? Next, thus we can define The distance traveled by it. The distance traveled by it. The distance traveled by it in a unit of time. In a unit of time. How we define the speed? How we define the speed? The speed of an object. We can define the speed of an object as the distance traveled by it in a unit of time. Have you understood this, children? It is the definition of the speed. Note it down carefully. Now we move to units of time. Speed. Units of speed. Okay. Depending on the need and context, the speed is measured in different units. Unit of speed in SI system is unit of speed. SI system. In SI system is meter per second. Meter per second. It is denoted as m by s. Okay, have you understood? Next, another unit commonly used. Another unit commonly used is kilometer per hour. Kilometer per hour. Okay, it is denoted as km by small h. Km by small h. Have you understood, children? What are the units of speed? Unit of speed in, we measured unit of speed in different units. Here the time is in kilometers 0. Okay. In 10 minutes it travels, the car travels 15 minutes, 15 kilometers, and 20 minutes it travels 25 kilometers. 30 minutes, at 30 minutes it travels, the car travels 38 kilometers. At 40 minutes it travels 60 kilometers. Have you understood? The car is here we are taking one example. The distance of the car, at different intervals of time. Okay. What is the total distance covered by traveled by the car? What is the total distance traveled by the car? 0 time 0 kilometers. 10 minutes 15 kilometers it traveled. 20 minutes it traveled 25 kilometers. 30 minutes it traveled 38 kilometers. 40 minutes it traveled 60 kilometers. It traveled different distances. Okay, in equal interval of time. Okay. What is the total distance traveled by the car? Total distance here 60 kilometers. It traveled 60 kilometers. What is the time taken to travel to cover the distance? 40 minutes. Have you understood? 40 minutes time taken to travel the distance. Okay. How do we find the speed of the car? We have already understood the formula. Average speed of the car equal to distance traveled by time taken to cover the distance. Okay. How do we find the speed of the car? To find the speed of the car, we should calculate the total distance traveled by the car and the total time to taken to cover the distance. Okay. So now here 60 kilometers. It travels 60 kilometers in 40 minutes. Have you observed? Okay. To express the speed of the car or speed of the vehicle, we have to express this in kilometers per speed of the vehicles in kilometers per hour, or either kilometers per hour or meters per second. Okay, speed of the vehicle must be expressed in kilometer per hour or meter per second. Here in this problem, the total distance covered by the car is 60 kilometers and time taken to complete the traveling taken 40 minutes. So these units are different. So it is wrong. We have 2 minutes. 40 minutes changes into hours. Have you understood? So total distance covered by the car is 60 kilometers. Total time taken to cover the distance 40 minutes. So we have to minutes, 40 minutes to, we have to change this 40 minutes to hour. Okay. So speed equal to distance by distance traveled by time taken. So we have to change this 40 minutes to hours. So 1 kilometer equal to 1000 meters. Okay. 1 hour equal to 60 minutes. Sorry. 1 hour equal to 60 minutes. So 40 minutes equal to 40 minutes equal to 40 by 60. 40 by 60. So 40 minutes equal to 2 by 3 hour. Okay, what is the speed of the vehicle? What is the formula to find the speed of the vehicle? Speed equal to distance traveled by time taken. Okay, what is the distance traveled? What is the total distance traveled by the vehicle? 60 kilometers by time taken to cover 2 by 3. 40 minutes changes into 2 by 3 hour. So 2 by 3 hour. Okay, now we have to calculate this. 3 by 2 kilometer per hour. Okay, understood? 30 times 90 kilometers per hour. The average speed of the car. Now we have to find the average speed of the car is how much? 90 kilometers per hour. Have you understood? Let us move to solve the following problem. The speed of the bus is 70 km per hour, whereas the speed of a car is 12.5 let's move to worksheet 5. First we have to fill up the blanks. The speed of the vehicle, the formula of the speed. Okay, speed equal to dash divided by time taken. Okay. Next, unit of speed. Unit of speed in SI system is dash. Okay. Next, solve the. Okay. Unit of speed in SI system is dash. Okay. Solve the problem. The speed of the bus is 70 km per hour, whereas the speed of a car is 12.5 km per second. Which vehicle moves faster? Already we have learned in this class, so you have to find this answer. Which vehicle moves faster? Okay. This is the final class in motion and time. We have met in next. We will meet in next classes.